Hello there! How does Speedy acquire its targets? The Spitfire Automatic Turret automatically shoots enemies, but have you ever wondered how it even detects and aims at targets? Well, let's have a look. It's a bit of a different video today, as we are not going to discuss about physics much, but instead we are going to talk about technology. As of the making of this video, I'm about to get my generalist engineering degree, and I have a minor in data science, which means I have some expertise in artificial intelligence. And I wanted an excuse to talk about AI on this channel, so here it is. So, how do you automatically acquire a target? The starting point would be to use a thermal camera. That's a very simple way to detect a person in an image, but I don't think that's what Speedy over here is using. Indeed, not only it would make some vehicles distracting for the turret, but I also suspect it wouldn't work very well in the heat of India. Which is why I think you need to slap an AI on this bad boy. Yeah, I know, when you have a hammer, everything is a nail to you. So me proposing an AI might seem amusing, but let's dive in anyway. First, let's discuss what an AI is for such a system. For a long time we have used AIs that were hard-coded, and that's still the case today actually. We tell the machine that if you have this, then you do that, and it works pretty well. Indeed, this is what you are familiar with if you regularly play video games, and developers have become very good at it. But this approach has its limits. While it is reliable and most importantly very predictable, it also often lacks generalization abilities, meaning that it cannot address situations that weren't foreseen during the development process. And this is where machine learning comes in. First, what is machine learning? There are situations where hard-coding a behavior is just too complex. So instead you just ask the machine to develop the behavior you want by itself. From a certain input, you want the machine to give a certain output. So you give it data, and through a mathematical iterative process, the machine will by itself adapt its internal configuration to give the outputs you want. This process is called training, and it is analogous to a learning process. For instance, imagine you are a student and you need to prepare for an exam. One way to do it is to do a series of training exams. If these training exams are similar in content and structure to the final exam, and if you do enough of these training exams, then when the actual exam comes, you will be trained and ready. Well, that's exactly how a machine learning algorithm works. You give it training data, and when training is done, the algorithm should be able to reliably take on new unseen data from the real world. So, how does that help with target acquisition? Well, deep learning can be excellent for object detection in an image. But I want to make something clear. Deep learning is just a subset of machine learning. Not all machine learning algorithms are neural networks. In a lot of cases, neural networks are just completely overkill. Let's explain what is a neural network. Neural networks are the product of biomimetism, which is a problem-solving method that relies on copying nature. After all, why would you come up with the solution to a problem when millions of years of evolution have already addressed the problem? In the case of learning, nature has come up with brains. So what about copying how brains work to develop a system that learns by itself? This is what a neural network is. It's a simplified model of a brain. Therefore, to explain how a neural network works, we need to explain how neurons work. A neuron is a brain cell that takes in signals and outputs another signal. The cell receives signals from other neurons through dendrites. Depending on the inputs received, the neuron will send or not a signal through the axon, which is the output. That output will then go to other neurons and the process repeats. Importantly, not all the input signals have the same importance. For one particular neuron, certain dendrites will play a bigger role than others. When you learn something, you create new connections between neurons. You also change the importance of certain dendrites for certain neurons. A neural network in a computer mimics all of this in a simplified way. Neurons are a mathematical function that takes inputs from previous neurons and outputs the result of the function to the next neurons. And how does such a system learn? Well, each input of each neuron has a weight associated to it. That weight is the mathematical way to represent importance. If the weight of an input is big, then this particular input matters a lot to the neuron. The learning process therefore aims at manipulating these weights in such a way that they will converge to values that allows the neural network to perform the task you want. Now obviously these neurons do not do much by themselves, so you need to put them in a neural network. Depending on the neural network, the neurons will sit differently. The example on screen is very typical of what a neural network is. You have an input layer, an output layer, and the signal is fed forward. Every layer between the input and the output layer are called deep layers, hence the name deep learning. I won't dive in too much depth here, because the subject is really complex and requires quite a lot of math to grasp. But I want you to take away one thing from this. Thanks to their structure, neural networks have the power to approximate nearly any mathematical function you can think of. The only thing you need to provide in order for that to happen is data. Give them training data and they will converge to the mathematical function you wish to have. Let's take an example. Let's say I want the following mathematical function. It's a function that takes a photo as an input, and the output tells me whether the image contains a dog or a cat. For a human being, it's very easy. This is a cat, this is also a cat, that's a dog, etc. Oh, by the way, the two cat images are not real, they were actually generated by an AI. But what if you wanted a mathematical function, an equation that does what I just did? The problem is too complex to come up with something, so instead you use a neural network to approximate that ideal unreachable function. All you have to do is feed to the network a series of images containing a cat or a dog, with each image labeled as either a cat or a dog. And after a lengthy training process, your neural network will be able to do just that. Here is me trying it out. So, is this what the Spitfire uses? Well, no. Actually, the Spitfire Turret works in a very similar way. It just uses a slightly different technology. You see, to a computer an image is just a table of numbers, called a matrix. These numbers represent the intensity of red, blue and green for each pixel of the image. So a more efficient way to address that is to use convolutions, which are a type of operation you can apply to matrices. So for image treatment, a convolution network will do a better job. But for the most part it works just like a neural network, so don't worry about the details. Now, finally we can get into what Speedy uses. I think the Spitfire Turret uses a particular type of network used for object detection. Personally, I am familiar with the YOLO architecture. YOLO stands for You Only Look Once. It is a neural network that has been trained to detect a certain list of common things, like people or everyday items. And here is a demonstration of it in action. The really nice thing about YOLO is that it's performant enough to work in real time on a video live feed. If I were to develop Speedy, I would put cameras on it with the YOLO algorithm inside. And that's it. Problem solved. There is really not much more to it. In fact, I'll be showing footage of me using it in Watch Dogs 2 and Cyberpunk 2077. Looks cool, right? Now I want to make something very clear. I do not condone cheating, which is why I didn't try this algorithm in PlanetSide 2. While it would probably make for a better segment for this video, I am not going to use this in a multiplayer game. However, this gives me a nice opportunity to talk about articles I've seen pop up recently. Articles about cheating software using artificial intelligence. I wanted to talk about this because it is both interesting and worrying. I suspect these cheating software use technologies like the one you see here. And that's a problem because it's not using any data stream inside the game. Instead, it's working completely outside of the game. This works by just looking at the image of the game just like you do with your eyes. If you hook that up to a program that then takes decision and simulates mouse keyboard inputs, you would end up with an aimbot software that works by simulating human behavior. And because it works outside of the game, I don't think it would be caught by anti-cheat software. In fact, I don't know if Cyberpunk or Watch Dogs have any anti-cheat software, but that program right there hasn't been detected at all. And anyway, you could have the aimbot running on a completely different machine to the one running the game, completely bypassing the anti-cheat software. It is very interesting, but it does worry me a bit about the future of shooter games. So, back to Speedy. How does it acquire its targets? I would argue that it is simply using a neural network that detects soldiers on a video live feed. And that's it. Then you could train that neural network to only recognize enemies. Also, and that's the interesting part, I think you could train the object detection network to recognize cloaked infiltrators. After all, if you have a trained eye, you are able to see a cloaked infiltrator yourself. And as a general rule of thumb, if a human being is able to do something, a neural network might be able to do it too. Sometimes it will be even more effective at that task. So if you gave images of cloaked infiltrators to Speedy's neural network, I think you would be able to train it to detect cloaked infils. That would be cool. So what are your opinions on these new AI-powered cheating softwares? How do you think Speedy works? Let me know in the comments. You can also subscribe if you enjoyed the video. You can also catch me live on Twitch where you won't see me use YOLO on a video game because I don't like cheating and I don't like cheaters. Thank you very much for watching.